Okay, good morning, everyone. Welcome to the Elixir Friday Coffee, where we are presenting tools and services which are available through the infrastructure. This time, the talk will be delivered by Michal Malý from Laboratory of Structural Bioinformatics Proteins from Institute of Biotechnology. Michal is from lab of ELIXIR-CZ, and he'll be talking about the WebMMB, where MMB probably means a service. So, Martin, the floor is yours.
All right, good. Morning, everyone. I hope you can hear me. Well, in the beginning, I have to apologize a little bit because I had to put this talk together on a quite short notice. And honestly, WebMMB is not exactly at the state where I would be like super excited to talk about it. But I decided, to at least give you an idea what WebMMB will hopefully be one day, because it's like still a rather fresh project, and it's still more of a prototype and an idea rather than a finished service. As you can see, I try to come up with a clever subtitle, but all I came up with is the way it was, because I imagine that most of you don't know what MMB is, and therefore you will have a bit of a hard time imagining what MMB could be. So MMB is like can I make my what is a shorthand for macromolecule builder, which, and like in like the most boring way how to put it would be that MMB is like yet another tool that can build 3D structures of macromolecules from a given set of rules. You could use all kinds of input as like a primary sequences, templates, templates, or like or some and stuff, and then you can apply all kinds of restraints, base person interactions, and across basically whatever you can. I think of, because MMB is rather flexible in this way. MMB itself is like a rather old project. It's been developed since around 2007. It originated at the Stanford University, and then this Sam Flores has moved to Stockholm, so is his hint, and he's still kind of working on it and maintaining it. It's not as active and alive as it used to be, but it's still very much alive and useful. It's mostly focused on nucleic acids, but it can do a bit more than that. Well, MMB uses the basic principles of molecular mechanics. Where you basically apply Newtonian physics at a scale where you perhaps shouldn't really have to, but this is known to work, and it modes, and in a lot of cases it's a reasonable approximation to treat your structure as balls and springs representing molecules and bonds, and you can then apply various forces to shape the structure in a way that you want. Well, and the one key difference between MMB and I would say any other is similar to out there, is that MMB uses internal coordinates to represent the spatial properties of structure. Well, if you're not familiar with the term, then internal, then like this is basically a simple comparison. Then in usual Cartesian coordinates, you have like XYZ coordinates, and all the bond distances and angles are kind of implicit, because you know where your atoms are, and when you know that, you can like derive the distances and the bonds. With internal coordinates, it's exactly the other way around. You define the distances and the angles, and that's and the XYZ coordinates is what you imply. Well, it's like in practice, you would actually build like a tree of roots from which you go. Well, it's not exactly important to describe the principle, but the takeaway message here is that the bond lengths and angles are like the input. This is what internal coordinates work with, and this can be useful because if you have a geometry defined explicitly like this, it's very easy to rigidify parts of the structure and say like, okay, I know that this bunch should be like 40 micrometers. This angle should be like, I don't know, 95 degrees, and you can specify that explicitly. So we can have a parts of the structure which are perfectly rigid, and other parts which can move and whose position you can calculate. This can save a lot of computation time, and actually a lot, because MMB itself, is not particularly well optimized, like, but it still runs quite fast, The problem is that this internal coordinates idea, it's not like a universal solution, because if it was, everybody would be doing it. So, well, if you need to go back between the Cartesian and internal coordinates, that's costly, because there is a lot of calculations involved there, and unfortunately it turns out that sometimes you basically have to do it. There are some forces and some interactions that you can't easily do in internal coordinates without converting back and forth. So, but it's still like an interesting approach, and it's useful in some ways. Like MMB itself, has proven itself as a useful tool, in various applications. And one of the most, well, one thing that we are using it for the most is density maps fitting, where you have where you have an electron density structure, electron density map, and you have a structure, and you are trying to fit the structure into the given density. MMB is very good at doing that, and it's actually quite fast at doing that. So you can work with rather large structures and maps, and you don't need like a cluster of 200 computers to get anywhere. Right, so like, what's WebMMB? So as the name kind of gives away, it's our idea to expose the functionality of MMB over the web. Because MMB itself, it's like, it's a kind of a tool, which is not most convenient to use, I would say. So one of our ideas is to provide like a more convenient access to MMB, and eventually integrate it into some more complex pipelines. Well, as I said in the beginning, this is still kind of like a fresh project, so we don't really know where we're going, but basically this is like the basic overview, where this is like our nice black box that hopefully you will not ever have to interface directly, and we will make it accessible over the internet in some like a well-defined way, either through a browser with like a nice GUI, or in a programmatic way, which will enable some people to integrate MMB into their own pipelines. Well, the current state of the project, it is basically what you could expect. You feed MMB with some data, it will do its thing and get you the refined data and maybe some additional metadata as a result. This is probably not like the most the most revolutionary idea, but like as I said, the project is still kind of fresh. So what we do have is like, well, we have a proof of concept that we can actually do it, and we have a working prototype, which is useful to some extent, but it's still very much a prototype, because we are still kind of figuring out what this thing it could be and where we actually want to go with this, because ideas, are emerging kind of as we go. So we're still kind of, trying to zero in on the final set of ideas. We are currently trying to make WebMMB to be more useful for for density fitting because, well, at least Pavel Plevka or actually it's in collaboration with the samplers are using it for some quite advanced density fitting of viral DNA, and we're also trying to integrate it in NATCO, which I believe Jirka talked about a few months back, which will hopefully make it even more useful. Well, here's one question. Can you use it? Well, technically you kind of can. There is a link which you can visit so that you can be sure that this is not all like a hoax. We actually have this and it actually exists. But I'm not sure if you actually want to, because your current experience probably would not be exactly great. But as I said, it's a prototype. We're working on it and we're making a good progress, I would say. The more interesting question is like, can you contribute? And definitely yes, because like the thing that would be very helpful for us is would be to know if there are like some kind of pipelines where people might be interested in using MMB, and what can we do to accommodate you to make it easy for you to use MMB and hopefully create some kind of collaboration. Hopefully. Well, I mean, I really wish I could end this very brief and talk on some like a nice conclusion. Unfortunately, I'm not really sure to do that. I mean, if you're interested, I could show you what the demo looks like right now, but it's not going to be like all that interesting. So as I said, this was like a quite quickly put together talk. So I'm afraid so I guess this is what I have to say about it right now. So are there any questions, suggestions, input?
Maybe you can show the
Yeah, maybe I can try to show the demo, but well, okay, let's hope the screen sharing function doesn't break. Can I like share if I share a window with this, is this gonna work? Okay, so this is like the very quite improvised web GUI where I can create a demo job and let's see if I can try to demonstrate how this density fitting functionality could work. Density map file. Okay, so this is like one of our examples where I can basically, or where I can provide the structure and the density map, and I can specify that chains A, B, and C will be rigid, and the remaining two chains A, P, and T will be flexible. You will figure out why once you see the structure. And now I can just start the fit and hopefully something will happen. Yeah, there we go. This is the density map, and it will take a little while for the structure to appear. Come on, yeah. There we go. And you can see that this is one of the chains that's being fitted, and this is the other one, I hope. Yeah, it's not very easy to navigate, And if we were to run this for some time, you would see that that these two chains that are flexible will move around in this like a block of atom density, and this remaining green chunk would basically just stay in place. And like considering that this is using just a single CPU core on a rather average server, it's not, well, it's actually rather fast. I mean, you can see that that there is definitely something going on. Yeah, it's a demo job that's basically just used to test the functionality. But this is like one of the applications that we are hoping that MMB could be useful for. Yeah, I'm afraid this is all I had for today. Thank you.
So no questions at all?
Oh, I probably have a question. So the package is actually dedicated for the people who would like to actually start modeling, or for the advanced users?
We would love to bring to put MMB to hands of let's say less experienced people, because we believe that there is a lot of functionality that is that's useful, but it's difficult to access because MMB, is one of these things where you have to put a lot of effort into figuring out how to use it. If we make it more accessible, we would like to put it to bring it into hands of people who are more of a biologists than technically minded people, if that makes sense.
Mm-hmm. So another question is, what do you use to visualize the structures? Molstar.
Yeah, it's like our own plugin, which is slightly modified for the purposes of MMB, and it's actually very useful in this way.
Probably another question regarding let's say the modeling the molecules which are in interaction. Can you model, let's say, the interaction between the proteins or protein DNA or something of that kind?
Yeah, we can. The issue with MMB is that that being like a molecular mechanics thing is that you have to provide some way how to calculate the appropriate forces, that it describe the interaction. So assuming that you can describe the force, we can do it, because MMB is very flexible in terms of what it can be taught to do. It's quite easily extendable with custom forces and custom interactions, as long as you know how to describe it.
Okay. So is there any other question? I don't see any.
Maybe I'll just,
yeah.
Maybe I'll just give an example, for this protein or whatever interaction, you can, for example, use restraints. Michal mentioned that from NMR, from chemical cross-linking, or these kind of, that something is within a distance between something, so you can input it in MMB and let it evolve. So okay. It is really flexible. You can do many things.
So you can use your, let's say, the experimental data to somehow modify the process of the modeling, right?
Yeah, exactly. That's the main purpose, I would say.
Perfect. So I don't see any other questions. So let me thanks to Michal again, and please join us next Friday on 9:30. Thank you very much and have a good day. Bye-bye.
Thank you.